Hi, I am Selva and welcome to my YouTube channel. So in this one, we will see how to convert any Python code to Cython to make it run fast. And in the process, we will see how to make it run 100 times faster or even more. Now, this is possible because Cython is a language that basically converts all the Python code into C programming language code and make the Python code run as if it is running a C language code. Let's see how to Cythonize a given Python function. It can be a Python function, it can be a Python file, just a series of code in a Python file. It does not matter. In this example, we are going to Cythonize a given function, which in this case is SumFunc. It takes an argument k. It does not matter what happens inside this function right now. What we will do is we will first run this whole function inside Python. Just plain Python, we will first run it and measure the time. Measure how long it takes. Alright. Then we will Cythonize this, and then again measure the time again. Now here inside this code, I am importing, see here, I am importing the time module first, then I am importing from example, import SumFunc. So what does this example refer to? See this notebook here, my how to speed up Py, right? This notebook here is present here in this project directory. This example here refers to the example.py file, and inside this example.py, the same example.py is over here. I have opened it. This contains the function that we have defined. I have basically defined the function here. Now, this SumFunc that is defined inside example.py is being imported inside this code block. All right, I'm basically defining this function inside example.py and importing it here. Now, I'm measuring how long this particular piece of code takes to run. Initialize the time, run SumFunc. The value of k we have set it to 100 million. Alright. Then after the function is run, we are measuring how long it took. And if you look at the time taken, it comes to 13.78 seconds. Alright. So pure Python, if you use pure Python, the total time taken is 13.78 seconds. 78 seconds. Now we are going to Cythonize this file. What does that mean? What we need to do is, we are going to create one more file, but this time we will put an extension pyx. We'll create one more new file called example.pyx, and the content of this file will be the exact same as what we have in example.py. So what we are going to do is, I'm just going to right click, copy this and paste it here. All right. Now I'm going to rename this as example underscore cy. I'm going to call it a cy and pyx. Just to distinguish that we have two different files. Now inside the content of example underscore cy.pyx. So this is the content. There is no change in the content at all. Okay. Now only because I'm going to be importing this function, in order to distinguish the names of the function, I'm going to rename this function as SumFunc underscore cy. Alright. I'm going to save this. Now we will go back. We need to create one more file called setup.py. So inside setup.py, I'm going to import from distutils.core import setup. I'm importing the setup function from distutils.core. I'm also going to import Cythonize function from cython.build. From cython.build, import Cythonize. Then to Cythonize function inside setup, we need to pass in the names of all the Python modules, the .pyx modules that we want to Cythonize. So in this case, there is only one file here, one pyx file at this point. Pass it here and then save it. That's all. It's already saved. No change to make here. So first change was we created the pyx file, the same content as example.py. Second step is to create the setup.py with this content. Now, ideally, before doing all of this, you need to have the Cython package installed. If you have not installed it, you need to go to your command prompt. In this case, I'm using Anaconda prompt here. So I started Anaconda, and you need to run pip install Cython, Cython. If you have not run it already, I have already installed it, so it will show that the requirements are already satisfied. If not, you need to install it. Now everything is set. Finally, let's start building it. To build it, you need to call this particular command, Python setup.py. Call setup.py using this extensions, using this parameters, build underscore ext hyphen in place. So this is the command to build your Cython files. So on running this, if you look at the contents of your folder, notice here the contents of the folder here, it has created one C file, an additional .c file. It will also create a pyd file if you are in Windows. A pyd file is created additionally here if you are in Windows. If you are in Linux, it will create a .so file. Depending on what operating system we are using, it will have a different extension. It also created this particular folder build. It does not matter to us. Now, the Cythonizing part is also done. So, one more time, observe carefully what has happened. So, we started off with example.py file. We created this new file from this. The content of .pyx file is exactly the same as example.py. Alright, we created these two. Then we created setup.py file. Alright, and place some code here. Alright, this is what we had initially before calling the build command. Alright, this build command, before calling the build, this is the build command python setup.py buildx in place. Before we call this command, these were the files that was present here. Now on running that command, we have two additional files mainly, example_cy.c extension and a .pyd extension. In case of Windows, it will be .so extension for Linux. So Cython has done its job and generated the code in the C language. Now we can directly import the function from the module. So we are importing some func_cy. This is what we will use. We're importing this from example_cy. On running this, you can clearly see it is taking 6.28 seconds, nearly half of what it took earlier. So this is 2x improvement from our existing code, a huge gain nevertheless, but we can do better than this. So what we can do is on the existing function, we can add the C data types. For example, instead of assigning a value to a variable directly like this, a equal to 10, instead of doing this, you can add the keyword cdef, right? Cdef followed by the data type in C language, int in this case, followed by the name of the variable, which is a. You can leave it like this, or you can assign the value also here. This way you can define your variable as well as do the assignment as well. Now do this for all the variables that you are having in your Python code. So this is one step that you can do. Second thing is, for every function that you have, instead of writing cdef, instead of writing this, write cpdef. So here, see, this is how we define the Python function, right? Def, name of the function followed by the arguments. Instead of doing this, you can write cpdef, right? cpdef followed by the name of the function. Here inside the bracket, you can write what the variable data type is. Here is a full list of all the different variables available in the C language. You can use any of this, and if your variable is going to be a list, say you are defining a list a equal to say 1, 10, 20 and so on, right? If you're going to be defining a Python list, you can, and you know the length of this list beforehand. In that case, you can write short int within the brackets, write the number of items that list is going to hold. That would be the syntax for defining a Python list. So keeping these two changes in mind, let's update the sumfunc_cy function. We are creating a new version of this, cy2. See all the different changes that is happening here. We are starting with cpdef instead of def. This is one change. We will come to this part soon. Leave this for now. cpdef followed by the name of the function. Inside the brackets, write the data type of the variable that you are going to take. Then we have two different variables inside this function. Accum. Initially, we had accum equal to 2 alone. Only this part alone was there. Here we are writing cdef followed by unsigned long int. Now, why is this one? Because accum is a variable which we are going to accumulate the values, keep on adding more values, more numbers to this particular variable, because we are doing accum equal to accum plus I. Suppose if this value of k is a large number, we need to allow Cython or C language to hold for accum to hold the largest possible value, right? So unsigned will make it positive. Long int means very long integer. As much as possible, assign the longest possible value to accum that this particular computer can hold, right? So that way we are defining accum. Likewise, we are defining here, we are assigning the value also. And in the next line, we are defining I as cdef long int I. Since we have already defined k, we are not adding this here. All right. So this is not here, needed here. That's all. These are all the different changes. Now we are going to take the content of this function and place it in a new file. So go to the file explorer. I'm going to create a new file. I'm going to call it example underscore cy underscore static dot pyx. So inside this, I'm going to place the code that we had defined earlier and save this. So this is the first step. We have created the necessary function for this. Next, we need to go back to setup.py. Here we need to add the new file that we have just created. So let's add that. So example. So the name of the file is example underscore cy underscore static dot pyx. Pyx. Put it in brackets. Put it in quotes. That's it. So this is also updated. Now we are going to build the function. We come to Anaconda prompt and run the same code. Run this. This should generate the necessary .c and .pyd file for Windows. In case of Linux, again, this is going to be .so file. Okay, so this is generating the code, finished code generation. And if you go back here, you should find a cy static.c. So this is generated here. All right. And we also have a pyd file to be generated over here. I think this is the pyd file. There you go. So we have the two files that we need. Now that this is generated, we should be able to run the code. So coming back to the notebook, we can now import sumfunc underscore cy2 from example cy static. So this is now imported. On running this, see here the time gain. We went all the way from 6 seconds to 0.14 seconds. That's a huge gain in speed. We went all the way from 13.5 seconds to 0.14 seconds. All right. So can we do better than this? Yes, we can do better than this. What we can do is whenever Cython or C language runs this code, it does certain amount of checks. Like it checks for whether there is any zero division error happening or if there's going to be a missing value present in the code. So by default, it does all these kinds of checks before actually executing your function. You can configure it to override these kind of checks. That's exactly what we are doing here. So you need to do a C import of Cython. So inside your new code that we are going to define, you need to first import C import Cython. Right? In a new, we need to define a new .pyx file. Inside that, this is going to be the content of that file. So from Cython, we are going to import 4 decorators, 4 different decorators. There are more options. I'll give you a link where you can find more options. So we are checking for whether there is a zero division error or not. Bounce check, wraparound, none check. Again, we are going to repeat the process by placing this code in a new file. So let me create a new file. Let's call it example underscore cy underscore decor.pyx. Now inside this file, let's place the content of that. Save it. Then we will go back to setup.py. Here, let's add the new file that we just created, which is example underscore cy underscore, because it's having decorators, I'm adding decor or pyx, right? So that's it. We have saved this, close this, remove all these things, and let's go back to the Anaconda prompt. Let me clear the screen, CLS, and call the same build function. This should now again generate the .c file and the .pyd files. All good. So now if you look at the contents of this, our .decor underscore decor dot .c is there and then .pyd is there. So both the functions or both the files are there. Now we are ready to actually run the code. We can now directly import this function, sumfunc underscore cy3 from cy underscore decor. We have just created this. On running this, see it has come down from 0.14 seconds to 0.085 seconds. That is more than 100x improvement in speed overall. If you want to know more about the different decorators that you can use to override to speed up your Cython code further, you can visit this particular URL to know more. That's all for now. See you in the next one.